3.2, solving linear equations algebraically. So we worked yesterday in solving these systems through graphing and finding where the lines intersect. Well, now I'm going to show you a couple of different methods that work algebraically. The first one being substitution. And for substitution, we have to have two things that are equal to be able to plug it in. The reason that I can't solve for a variable for any of these equations is I have an x and a y, two variables. I need to make it so I only have one variable. So if I can replace one of these variables with what it's equal to, then I will only have one variable in the equation. So I'm going to take what x is equal to and replace the x in the top equation to give myself only one variable in the equation. And I always talk about money when I talk about substitution. We all like money. If I had $20, I would not care if I had a $20 bill or two tens. They look different, but they have the same value. So I'm going to take what x is equal to and plug it in to this equation. So instead of putting 4x, I'm going to put 4 parentheses what x is equal to, which is 2y minus 5, and then close the parentheses. And then I'm going to keep writing the equation. So I have 6y equals a 15. Now, as you can see, even though it's a longer equation, I'm going to only have one variable. So the first thing I'm going to do is substitute, okay? So after I substitute, now I solve this just like I would back in chapter 1. I'm going to distribute, okay? Distribute. So I've got 8y minus 20 plus 6y equals 15. I'm going to combine like terms, okay? So I've got 8y plus 6y is 14y minus 20 equals 15. I'm going to add 20 to both sides, okay? So I'm going to add 20. So I got 14y equals 35. I'm going to divide by 14. So step 5 would be divide by 14. And then I get y is equal to, I'm going to reduce the fraction. They're both divisible by 7, so 5 over 2. Okay, so after I do that, I have to plug my answer back in. So plug back into the original equation. Now, you can plug it into either one of these, but I'm going to choose to plug it into the equation that's already solved for x. So I have x equals 2. Instead of putting y, I know what y is equal to. It's equal to 5 over 2 minus 5. And you would get x is equal to 5 minus 5, which is 0. So I have the ordered pair 0, comma, 5 over 2. Again, all of these problems that we're doing today, we're going to get an answer that's an ordered pair. So once you solve part of it, you have to make sure you write your answer as an ordered pair. And this is, again, using the substitution method. So let's take a look at a couple more of these substitution methods. I'm going to talk through it, and then I'll put the list up of things. So in this problem, I have y by itself. So I'm going to take whatever y is equal to, I'm going to plug it into the top equation here for y. So I have a negative x plus 2x minus 2 is equal to 1. Again, I put parentheses just to make sure I know if there is a number out here, I distribute it. In this problem, there is no number out here, so I don't need to worry about distributing anything. I'm going to combine like terms, negative x plus 2x minus 2 equals 1. I'm going to add 2. And I get x is equal to 3. Once I get x is equal to 3, I'm going to plug it back into the original equation that's already solved for the missing variable. Y equals 2 times 3 minus 2. Y is 6 minus 2. And y equals 4. The nice thing about all of these problems, I could go back and plug them in. If I plugged in 3 for x and 4 for y, I would get negative 3 plus 4, which is 1 equals 1. I will always get the left side equal to the right side. So you can always go back and check these problems, okay? Let's go ahead and do one more substitution. So again, this one I have x by itself. So I'm going to take what x is equal to and plug it in up here. So I have 2 times 2y plus 6y equals 15, which is 4y plus 6y equals 15. 10y equals 15. I'm going to divide by 10. I'm going to write this as a reduced fraction, and I get y is equal to 3 over 2. Okay, I'm going to plug it back into the original problem that's already solved for itself. So I get x is equal to 2 times 3 over 2. I get x is equal to 3. I get the order pair 3 comma 3 over 2. And again, I could go back and plug that into both equations, and that would be true. So here is the steps to solving this. Okay, we need to get a variable by itself. Most of the time, a variable will already be by itself. We're going to substitute the equation into the other variable. We're going to solve for that variable, and that solving could be distribute, combining like terms, what we did back in chapter 1. Then we're going to substitute that value back into the second equation to get the second value, and then we're going to write it as an ordered pair. So that's substitution. The second method we're going to learn is elimination or combination. This can be really, really easy if the problem is already set up to eliminate or to combine. So what we need here is we need opposite coefficients with the same variable. So the first problem that I do, you're going to see that it's lined up, okay? And I have opposite coefficients of x's. So if I were to add down, my x's simply cancel. I'm going to add down every single one of these columns. So 8y plus negative 5y or 8y minus 5y is 3y. And negative 26 plus 8 is a negative 18. Now, as you can see, I couldn't solve these up here because they had two variables. I only have one variable now, so I can go ahead and solve. Okay, and I get y is equal to negative 6. That's not my answer. That's part of my answer. I have to go back and plug it into one of the original equations. It doesn't matter which one you choose. I'm going to choose the top one here. Again, so I just rewrote it. Plus 8 times negative 6 equals a negative 26. And I'm just going to solve this. Negative 4x minus 48 is equal to negative 26. I'm going to add 48. Solving for my x, negative 4x is equal to a positive 22. Divide by 4, negative 4, and I get x is equal to a negative 11 over 2. So I have the ordered pair negative 11 over 2. So again, the ordered pair negative 11 over 2, comma, negative 6. Again, as I'm doing these problems, the key is getting opposite coefficients. So we may have problems where they're not opposites. Okay, that's when they get a little bit harder. And we can do these problems many, many, many different ways. The first thing you have to do is you have to ask yourself, what variable do you want to cancel? Okay, and some of us are better with our multiplication than others. There's easier numbers to multiply, and then there's problems that make the problem a little bit harder because they have larger numbers. But still, there's a method to be able to solve these. So this problem right here, I can see that I can make these x's opposites. Okay, I already have a 4 here. If I multiply the entire top equation by negative 2, okay, and you might be asking, well, where did I get negative 2 from? Because I said I want to cancel the x's, and I need to make them opposite. So I'm going to multiply and distribute here this negative 2 to all three of these, which would be a minus 4x plus 8y equals a negative 26. Okay, so now you can see that I changed the top equation. It's still equal and has the same exact value, but I have a, make sure that looks like a negative 20. I have opposite coefficients. This 4 and this 4 will cancel. So this is no longer part of my problem because I changed that equation. Make sure you multiply everything and you pay attention to your signs. So I can add down, x's cancel, which I said I wanted them to. I add down and get 3y. And a negative 18. And then I'm going to divide both sides by 3, and I get y is equal to a negative 6. Okay, so I go back and plug it into one of the top equations. The top equation was 2x minus 4y equals 13. 2x minus 4 times negative 6 equals 13. 2x plus 24 equals 13 minus 24. 2x equals negative 11. I divide by 2, and I get the same exact answer. Okay, x is equal to negative 11 over 2, which again is the ordered pair, negative 11 over 2, negative 6. Now, there may be some of us that are not as good as with our numbers. So if I go back to the original problem, which was 2x minus 4y equals 13, and 4x minus 5y equals negative 26. If I say that I want to cancel the x's, but I don't recognize that I can multiply the top equation by negative 2, I can always multiply them by the other's coefficient. I can multiply this top equation here by 4, and this bottom equation by 2. Where did I get 4 and 2 from? Because they're the opposite coefficients of the variable I want to cancel. Okay, now you have to pay attention, because if I multiply 4 times 2, I get 8. And then 2 times 4, I get 8. I have to make one of these a negative so that they're opposites. It doesn't matter which one you choose, but you have to make sure you get opposites. So again, if I did this and distributed this 4, I would get an 8x minus 16y equals, and again, you just start dealing with a little bit larger numbers, a negative 8x plus 10y equals a positive negative 2 times 26. Make sure my math is right here. Oh, that should be an 8. Sorry, this should be an 8. So negative, this is an 8. That's why I'm writing the original problem right here. So that's an 8. Negative 2 times 8 is negative 16. So when I add down, my x's cancel, which I said they would, so they should. I get a negative 6y equals 52 minus 16. Okay, 52 minus 16 is equal to 36. I divide by negative 6, and I get y is equal to negative 6, which is the same thing that I got last problem. So you have to choose what works best for you. You can find numbers that multiply sometimes that make our life very easy. And then sometimes you have to multiply them by each other. Okay, so let's take a look at this equation, and let's realize, maybe I don't realize that I could multiply this equation. If I wanted to get the y's, I can multiply this by 2 and this by 3. Maybe I need to look at the x's and say, okay, I'm just going to cancel the x's. So I need to multiply the top equation by 5 and the bottom equation by 7. Now, last problem, if you look over here, I multiplied one of them by a negative. I don't need to multiply one by a negative here, because when I multiply 5 times 7, it will give me a positive. And when I multiply 7 times negative 5, it will give me a negative. So I will have opposites. So we're going to distribute here. Okay, 35x minus 60y is equal to negative 110. 7 times negative 5 is negative 35x. So I got opposite coefficients. I said I wanted to cancel the x's. They do cancel. 7 times 8 is a positive 56y. And then 7 times 14 is 98. So I punch it in. Make sure that your signs are correct. Negative 60y plus 56 is negative 4y equals a negative 12. I divide by negative 4, and I get y is equal to 3. So now that I have y is equal to 3, I can plug it into one of the original equations. Now, you can plug it into any one of these 4 because they're all the same, but the original equations have smaller numbers. So I have 7x minus 12 times 3 is equal to negative 22. 7x minus 36 equals negative 22, just solving for x here. Plus 36 gives me 7x equals 14, divide by 7, and I get x is equal to 2. So again, you can go back and check every single one of these problems. And if you are comfortable with Desmos, you could go and plug this into Desmos and this problem into Desmos, and they will intersect at 2, 3. But this is the method of linear combination, or also called elimination. Linear combination or elimination. Okay, so the next problem that I want to talk about, and I'm going to set it up for you. Let's say we said we wanted to get the y's to cancel, okay? And I did the multiplication, and I got a problem that looked like this. So I wanted the y's to cancel. And the y's do cancel. So I go down and I start adding down, and I notice that both my x's and my y's cancel here, and my numbers cancel. So I'd be left with 7 minus 7 is 0. There's no more variables. If there are no variables, this is when we have the same exact line. Okay, so when we have the coinciding lines from yesterday's lesson, so this would be infinite solutions. If everything cancels and you're left with a true statement, that means we have infinite solutions. That would be my answer here. Okay, if I had a problem that looked like this, okay, so again, I wanted to cancel this. Let's say the x's this time, and I lined them up, and I noticed that everything canceled. Sorry, that should be a plus. Okay, so I got a 0 equals, well, 7 plus 7, again, that original problem, I want this to be a 7, would be 14. So no variables left, but I left with a statement that's false. If I have a false statement, that means that there's no solution. These would be parallel lines. Okay, so if I'm going through the process of solving them, it's potential for me to get infinite solutions. That's when both variables cancel and I'm left with a true statement. It's possible for me to get no solution. That's when both variables cancel, but I'm left with a false statement, and I could get one solution like we did in the first two examples. Okay. If you have a problem that looks like this, okay, again, I want to cancel the y's. So let's say it looks like this. If my y's cancel, it's 3x plus 3x don't cancel. They're both positive, so it'd be 6x. But my numbers cancel. This is not a no solution or infinite solution problem. This problem right here can be solved. I can divide by 6, and I just get x is equal to 0. In order for it to be no solution or infinite solutions, I need both variables to cancel. Okay, and then I could just go ahead and plug in 3 times 0 plus 2y equals 10. 2y equals 10, divide by 2, y equals 5. So for this problem, I would get the ordered pair 0, 5 as my one solution. I'm going to put a couple of the Delta math problems up here just so you can see them. And especially we're going to do at least one word problem together.